images. So I want that if there is any doubt, let us. I think आप लोगों ने काफी सारे डाउट्स भी पूछे थे प्रीवियस क्लास में, तो एक बार क्लैरिटी आ गई थी या कुछ? इफ यू वांट टू डिस्कस वी कैन डिस्कस इट अगेन.
लास्ट न्यूमेरिकल है ना सर, वो सब मतलब
लास्ट
हाँ लास्ट लिया था वो कोसेंट्रिक न्यूमेरिकल वाला, वो जरा बताएंगे.
कौन सा वाला?
सर्कल्स ड्रॉ किए थे, मतलब तब मेरा इंटरनेट चला गया था, एक सर्कल्स थे और उस पे चार्ज ऊपर क्यू लिया था और सरफेस पे माइनस क्यू इंड्यूस हुआ था, तो उसका इमेज
नहीं,
प्रॉब्लम.
आई थिंक वो इमेज प्रॉब्लम से कहाँ था, वो तो बहुत पहले किया था. दैट वाज नॉट इन इमेज प्रॉब्लम.
सर आपने वो दिखाया था कि एट द सेंटर चार्ज डेंसिटी ज्यादा होगा और धीरे धीरे चार्ज डेंसिटी घटता जाएगा.
अरे दैट वाज नॉट स्फीयर भाई, आई दैट इज अ प्लेन ना, तो प्लेन पे तो सर्कल बनेगा.
यस सर वही बोल रहा है सर.
किशोर.
यस सर, आई गॉट इट सर.
हाँ कंचन, वो सर्कल है भाई, वो स्फीयर नहीं है.
सर्कल ही सर.
हाँ तो आई वाज टेलिंग दिस, देखो ये जेड एक्सिस है, दिस इज एक्स, this was xy plane, so this is the plane, okay, perpendicular to the board, and this was the charge q here, and this is infinite plane. So I was telling that if you calculate charge density at this point, it will be maximum because q charge is closest to this, yes or no?
Yes.
So as we go further in the circle, so I have to make the circle like this. This is not a sphere, a circle on xy plane. I was saying this, that if you go further and further, so like here charge density is maximum, but if you keep on going away from the center, the charge density will decrease. That I was saying.
Okay,
So
sir, clear.
this point will see maximum charge density. And let me tell you that if you wish to calculate the potential at some point here, with I told you na that this is replaced by
Minus Q charge.
minus q charge, image charge. This is called image charge, huh? And this distance was z, this distance was z. So what are the coordinates here, Kishore?
सर
What are the coordinates of q?
सर 0 0 Z होगा.
0 0 z. Very good. And what are the coordinates of minus q?
सर 0 0 minus Z.
0 0 minus z. What are the coordinates of this point where you want to calculate the potential? X y z. Correct?
Yes sir.
So if you wish to write the potential at this point, phi, it will be 1 by 4 pi epsilon naught q 1 by r1 minus 1 by
R2.
This distance is r1, this distance is r2. ज्वाइन किया है सारे लोगों ने या सुबह की वजह से? ये संडे वाला जरा माइंड मेकअप करो तो थोड़ा सा आराम से हम डिस्कस भी कर सकते हैं और थोड़ा आवर्स भी बढ़ जाएंगे ना. ठीक है?
Yes. Yes, sir.
यू कैन हैव योर टी ऑन योर टेबल बट मिस नहीं करना है. ठीक है? ओके.
Okay, sir.
So yes, so phi will be equal to q by 4 pi epsilon naught into 1 by, so what is r1? Under root x square
Y square.
x minus 0 square plus
y square.
y square. And this distance
Sir,
I shall
0
take
0 d होगा. Yes sir.
I shall take d so that it will not it cannot be variable, right? We have to put it at a fixed distance, right? So x square plus y square plus z
minus d bracket.
minus d ka whole square and minus 1 upon under root of x square plus y square plus z plus d ka whole square. So this was our purpose, that we wanted to calculate the potential. We got the potential. Is it okay?
Yes sir.
We wanted the potential, we got the potential. And please see, if I put phi 0 comma 0 comma 0, I am going to get 0.
0.
Even if I put x comma y comma 0, right? y0 means xy plane, z0 means xy plane, then also I will get 0, and this will be according to the boundary condition. This will be according to the boundary condition. Is that okay? Boundary condition follow कर रहा है ना?
Yes, sir.
So this is according to the boundary condition. And if you want to calculate the charge density, it is given by sigma is equal to minus epsilon naught del V by del N. I mean del phi by del N, whatever you want to write. V is potential, okay? So get ready for using V and phi, both has potential. This is a very nice formula, comes from the boundary conditions of electric field. So this is surface charge density, surface charge density, and epsilon naught is, permittivity of free space, V is potential, N is the direction in which the potential is changing. So like here you have xy plane, so it will be del V by del Z, okay? So please see that if you calculate sigma is equal to minus epsilon naught del phi by del Z, and at Z is equal to 0, because on the surface Z will be equal to 0, correct? So you will get the formula for charge density, and that will be sigma is equal to minus qd upon 2 pi x square plus y square plus d square to the power 3 by 2 at, you have to take x is equal to y is equal to 0. So let me just यहाँ पे ऐसे रहने देता हूँ. Like this. This is the charge density. And if you want maximum charge density, then what is this point? X is equal to y is equal to 0. So it will be minus q by 2 pi d square. देखो कितना simple सा आ गया. This is the maximum charge density. And as you move away, x and y will be finite. and they are sitting in the denominator, making the charge density decrease. Charge density will decrease as you go away from the center, as I told you. And the greatest thing is this, that if you integrate hmm,
माइनस एप्सिलॉन डेल v by डेल n वाला जो आपने फॉर्मूला लिखा था चार्ज डेंसिटी उसमें n क्या है?
n is the coordinate in which there is a discontinuity in the surface.
Direction.
The perpendicular. So here it will be z.
Okay, sir.
It is your xy plane, na? So you will be moving like this, perpendicular direction to the surface.
A.
So this will be perpendicular direction to the surface, okay? N. Okay, Varun?
Yes, sir.
Perpendicular direction to the surface. So, how interesting. And please see, if you calculate Q total, you will do integral sigma dA, yes or no? Huh?
Yes, sir.
And you take minus, right, sigma minus QD by 2 pi, take it in polar coordinates, r square plus d square to the power 3 by 2, put double integral and put, what is the small area on the surface? R dr d phi.
Yes, sir.
One integral is from 0 to infinity because the surface was infinite. One integral is from 0 to 2 pi. So Q will become, this will become 2 pi. It will cancel. Next integral will become minus integral 0 to infinity QD by under root r square plus d square 2r, right? Sorry, rdr. Only this much will remain. Now it is so obvious. What you will do? R square plus d square is equal to
T square.
t square. Integrate it quickly, you will get minus q. तो पूरे सरफेस पे कितना चार्ज है? माइनस क्यू चार्ज. Do it by putting r square plus d square is equal to t square. Integrate this. So देख रहे हो how mathematics is playing the role. Yes, Sri Lakshmi, are you understanding?
Yes, sir.
This you got it? How to integrate?
Yes, sir.
Yes. You will take r square plus d square is equal to t square. So r dr will become t
DT.
dt. So here for r dr put t dt and this will become t, right? So this will become, let me do it for you. Please ask if there is any doubt. It will become minus qd, r dr will become dt, t dt, and this will become t. T and t will cancel. So finally it will become t, right? T, limit will become t and put it back. So it will just become r square plus d square. QD by, sorry, what we will get?
सर उधर r² + d² पावर में 3/2 आएगा.
हाँ, it was 3/2, sorry, तभी तो गलत हो जा रहा है. It was r² + d² to the power 3/2. So here it is t dt, and when you put it t², it will become t cube, right? And then it will become t square. And when you integrate it, it will become -1/t.
Yes sir.
माइनस माइनस प्लस हो गया कि QD 1/t इंटीग्रेशन लगा
So
लिमिट
QD 1/t
T.
√ r² plus
d².
d, 0 to infinity.
Infinity.
So infinity will become 0. So it will become QD 1/infinity minus 1/d, which will become minus Q. See this. Now it's clear? Is it visible down? So that was so obvious that कितना आना चाहिए था total charge on the surface,
-Q.
-Q.
and that is coming also. So good, na? So this whole sheet, which was infinite, kept near this Q, will acquire total charge of -Q. And charge density will not be constant. It will be maximum here, and it will be decreasing as you move away from the center. Okay? So shall I raise it? Everything now? Clear? Okay. One more thing I want to discuss, and that is if you have this Q charge and this is distance d, this is infinite, grounded, yeah, infinite grounded metal sheet. Infinite grounded metal sheet at 0 potential. This was the case, na? And what you did? You made another system, Q charge here at distance d, no metal sheet now, but whole of this plane is at 0 potential. You can calculate by putting -Q charge, this all remain at 0 potential. So because of uniqueness theorem, the answers to this are the answers of this. Okay. But if you want to calculate interaction energy, see this. Interaction energy, if you want to calculate. So like you wanted to calculate force on this, huh? Force you calculated on this, na?
Yes, sir.
1 upon 4 pi epsilon naught.
Q square upon 4z.
Q square by 4z square. So you know force, so you can calculate the amount of energy needed to bring this charge from infinity to this point. That will be this interaction energy, right? यही तो होती है definition ना interaction energy की. So that should come out to be 1 upon 4 pi epsilon naught q1 q2. That means q minus q by r, this distance 2d, but that is not correct. Because for energy, you are using this also. It is interaction energy, na? So you are crossing this, you have to enter this region also. And you know, your uniqueness theorem is applied only in the region z greater than 0. So when you actually calculate the interaction energy through infinity to that, it comes out half of this. So you will get 1 by 8 pi epsilon naught minus q square by 2d. So that means how much you will get? Minus 1 by 16 pi epsilon naught q square by d. This will be the interaction energy. So this is very important, that it was okay to get the potential, okay to get the force in this region. But while calculating energy, you have to again go back to the basics and you should calculate it, that what is the amount of work done in bringing this charge from infinity to a point here. And that will come out to be itna, this much. Half of what you expect. Right here, half of what we expect. Okay? So this you should remember, that the energy will be like this. If you calculate it from infinity to this, you will get same. So I encourage you to calculate quickly. Can you do it? What was F between them?
1 by 4 pi epsilon 0 q square by 4z
Minus 1 by 4 pi epsilon naught. Q square by
4z.
4z square. So small work done. F dot dl. What will be small work done? From infinity to this point we are bringing. So small work done will be
minus 1 by 4 pi epsilon naught
q square by
4 pi epsilon naught.
16, na?
Yes, sir.
16 pi epsilon naught
Into dz.
dz by
Z square.
z square. So W will be q square by 4 pi epsilon naught minus 1 by z from infinity to a point D.
D.
dw माइनस नहीं आएगा.
Just wait. So this will become W is equal to 1 upon 4 pi epsilon naught minus q square by D. Minus आएगा finally.
Sir, 16
force is attractive, na? Sorry, 16. I have missed this. Force is attractive, na? So work done finally will come out to be negative. This is the interaction energy. U. So see, this is same, na? So if you directly apply that formula, you will be wrong here. Q1, Q2 by R. That is not working.
सर मेरा थोड़ा कनेक्शन चला गया था सर। ये जो हाफ फैक्टर आपने लिया वो किस वजह से?
वो ऐसे मैं ले नहीं रहा हूँ हाफ फैक्टर, मैं बता रहा हूँ कि इतना होता है, फिर मैंने कैलकुलेट करके दिखा दिया कि इतना होता है. What you expect is this formula, na?
Yes sir.
For energy between two charges. But for this, if you use directly this, you will get wrong answer. Okay? Because you are using this region also, which you can't do. Because your Poisson equation is only good for z greater than 0. You can't put another charge. बट यहाँ पे तुम ऐसा कर ही नहीं सकते. एनर्जी के केस में तो तुम्हें पूरा ही दोनों चार्ज को यहाँ से लेके आना पड़ेगा, अरेंज करना पड़ेगा. So that's why you are getting unexpected answer. So then we calculated it actually and we saw that it is the same. Okay?
Yes sir. Sir also charge is imaginary, no?
Sorry? What?
Sir also that charge is imaginary.
No, not imaginary. You are putting it here. You are making another system. Okay? Not imaginary.
सर
Yes?
सर मुझे ये पूछना था कि
हाँ.
अगर ये वाली कॉन्फ़िगरेशन मतलब ऐसे यूनिकनेस थ्योरम मतलब अगर Q x डायरेक्शन में और Z Y प्लेन ऐसे हो 0 V इक्वल्स टू 0 पे तो हम ये अप्लाई करेंगे उस पे?
हाँ, why not? Why not?
ओके ओके.
अरे you tell your system.
लाइक x लाइक Q इज जैसे अभी तो हमारा Z में है तो Q इज इन x एक्सिस along x axis and plane is along zy.
This is at D.
हाँ जी. Yes.
Now D is in X. So you
Yeah.
will make a system like this. This is your YZ plane. This is charge Q. This is at X or D, some D distance.
Yes.
And this is D minus Q. So this is your new system.
Okay, sir.
So everything you will write in X now.
Okay.
Okay. So now the charge density will be calculated minus epsilon naught del V by
Del
del
X.
X. Good question, Parampreet. देखो, now this is your charge density formula. Yes?
Yes, sir.
Because N was the perpendicular to the surface. And what will be the interaction energy now? Half into 1 upon 4 pi epsilon naught minus Q square by 2D. Got it? ठीक है? Anything else? So method of images is a very, very powerful tool, but it will not be always very easy to apply it. As you see in the case of method of images, for a spherical conductor. Okay. So like suppose you have a sphere like this and radius, there's a charge Q kept here. This is center O and there is a point P where you want to calculate the potential. This is R, this is theta. Its radius is R. Radius is capital R. Okay. And this is kept at a zero potential. Zero potential. So a point charge Q is situated at a distance small a from the center of a grounded conducting sphere. So this is grounded conducting sphere. Grounded conducting sphere. Okay. And we have to calculate the potential at the point P. So what is the difficulty? Find the potential at P. We have to calculate the potential at P. What is the difficulty? This is the charge Q. This is the conducting sphere. What is the difficulty in calculating potential at P? Tell me somebody.
Surface नहीं मिलेगा.
हाँ?
Induced charge की distribution हमने
Yes, very good. और भी कोई बताओ. Certain you don't tell. Anybody else? Lakshmi?
Sir, we need to discuss about the induced charge first, and then.
So think it in as a very simple problem, Lakshmi.
Okay.
This is Q charge. You can calculate very easily potential at P. Yes or no? Because of this Q charge, it is so simple to get the potential 1/4 pi epsilon naught Q by R. Huh? But problem is because of this charge, this whole conducting sphere surface will get induced charge distribution. And you have to take the contribution of that induced charge also at the point P once you are calculating the potential. That is the problem. Yes or no?
Yes, sir.
So the same difficulty that we encountered on the plane sheet is now we are encountering on the plane, on the surface of the sphere. So this first of all understand. So if I change this problem to an image problem, what I am going to do is I will put O at the same place and then I will put image charge Q dash and then I have a charge Q which I can't disturb. So let this is the distance small a and this is the distance small b. And this is the point P where you want to get the potential. Now this distance, and this distance, because you need to get the potential here, Q dash charge is kept at this point. This is small r. This is R1. This is another charge. Let us take it R2. This angle is theta. Yes or no? What is the potential at P? 1/4 pi epsilon naught. This you should tell. Q by R1.
R1 plus Q dash by
Q dash
R2.
by R2. इतना तो सबको समझ आ रहा है? So what we have done to change this problem, we have removed the sphere, but the surface still exists. Yes or no? You have removed the sphere, but the surface still exists. Surface R, that still exists. And at the surface, still potential should be 0. Am I right?
Yes, sir.
Yes, sir.
So when this R will become equal to capital R, at that point potential should be 0. Correct? So apply to get the value of R1 and R2, apply the cosine law. In this triangle, what will be the value of this R1 and then get the value of R2? R1 is this. So R1 square will be equal to, take this triangle, R square plus B square minus 2 RB cos theta. So R1 we got from here. R2 square is R square plus A square minus 2 RA cos of theta. You will put it here, and then you will put small r is equal to capital R, phi p is equal to 0. So when small r tends to capital R, then phi p must tend to 0. That is the boundary condition requirement. So as you do this, you will get the value of induced charge, that what amount of induced charge to put and where to put. Okay, that we will get. So the calculation is little large, so I am not doing it, but the final result you will get is very, very smart. So Q dash is minus R by A Q. This is the induced charge that you get after this, and the distance B is R square by A. So these two things you get, and they are, ये दोनों objective question में पूछे जा चुके हैं. Because final result, you see, induced charge जो आप रख रहे हो, this distance was given, it was B, and A is the distance where the induced charge is kept, right? From the center to A. So the induced charge must be negative, yes or no?
Yes, sir.
Yes, sir.
Yes.
Negative.
और Q के टर्म में होना चाहिए, Q के हिसाब से ही होना चाहिए ना, जैसे पहले Q और माइनस Q था, तो अभी भी रिलेशन में Q तो आएगा ही ना, Q का कुछ अमाउंट होगा, राइट? सो दैट अमाउंट इज R by A. If your radius is 5 centimeter and you have put the charge at 2.5 centimeter, what is the amount of charge that is kept? Minus 2Q.
Minus QR by A.
Minus 2Q. Okay. And what is the distance? B is equal to R square by A. So A is equal to
10.
R square by B. That is the distance.
Sir, A should be less than or greater than R. Capital A, small a.
A will be less than capital R.
Sir, A should be greater than capital R, no?
A, just wait a second. Where that thing will come? It will come here, na? So that it should not become.
सर क्योंकि चार्ज का मैग्नीट्यूड कम होना चाहिए.
लेकिन सर ए इंड्यूस्ड चार्ज का है ना.
सर आउटसाइड द स्फीयर रखेंगे तो पोटेंशियल 0 नहीं हो पाएगा स्फीयर पे.
I think it depend करेगा कि just a second, just let me think कि ये basically कहाँ पे ये relation आएगा. When you put it equal to 0, so it is not giving any condition that what it should be. It is just minus r by a, whatever is that value. Okay.
बट एक पर्टिकुलर कंडीशन पे यदि r a के इक्वल हो गया तो
मतलब there is no condition. You can take the value of q dash depending on the value of r and a. So a you have to get the
Sir.
value. हाँ.
सर ये जो b है
हम्म.
b का वैल्यू तो
फिक्स है. b is fixed.
नहीं सर, b का जो वैल्यू है वो तो रेडियस स्फीयर के अंदर है, तो
ना
उसका
ना
डिस्टेंस
no. b is much greater. b is greater than r.
सर मतलब जो
नहीं,
हमारी
बट
question
ईमेल
में
अरे
चार्ज
b भाई ये स्फेयर है, b यहाँ रखा हुआ है, ये कैपिटल r है. This much is capital R.
Sir, A is the induced charge, distance between induced
So
charge and the
b
center.
is greater than a for sure. Okay, and a is a distance from O to some point such that it is that distance such that if we put q dash charge here on the surface, potential is always zero. So if I draw a surface from here like this, so on this surface the potential should be zero. So that is that distance a and that is that charge q dash. Okay. So like suppose b is 5 centimeter and radius is, if we take it like this, suppose b is equal to, suppose I take 5 centimeter and the radius is suppose 1 centimeter. Okay. I can take it like this. So a will come out to be
5 centimeter.
no.
0.2 centimeter.
A will
0.2.
r square by 1
0.2.
0.2.
1 by 5 na.
Yes sir.
So it will be 0.2 centimeter. So the calculation is like this. अब ठीक है, numbers के term में समझ आ गया ना?
yes sir.
And in this case, what will be the charge that will be kept? Q dash minus 1 by 0.2 Q.
minus
Right?
5
Hmm?
minus 5
minus 1 by A. A is 0.2. So minus 5Q. So see, it is like this. समझ आ गया?
Sir, it implies that A is always less than R.
Yeah. It implies that A is always less than R. Na? Because B is greater than, because B is greater na? So that's why.
Yes, sir.
So in terms of number, it is clear, everything?
Sir.
Okay.
Sir.
बोलो.
जो इंड्यूस चार्ज q डैश है वो इनसाइड द स्फीयर ही लाई करेगा, जैसे यदि सरफेस की बात की जाए।
स्फीयर तो गायब हो गया ना,
स्फीयर गायब हो गया,
अब सरफेस है खाली। दिस इज द सरफेस.
yes sir.
This surface will have zero potential following the boundary condition. Okay. So this was a problem related to sphere image problem, and we have calculated everything, and even we can calculate the value of the value of, because now q and q charge is there, you can calculate the value of force also, right? Force क्या हो जाएगा?
1/4 pi epsilon naught q q dash
B
by
minus A.
b minus a whole square.
लिख लो, write it. So everything is clear. Now I can erase. Okay. If you want to go into the details of the derivation, you can see it from Griffiths. But for a spherical case, we should know this expression so that we can use it. And please understand why it is called image problem. I must do one question just to explain you why it is called image problem. So suppose you have grounded perpendicular conductors, both are grounded, and a q charge is placed here, q. I want to understand, I want to get the potential at any point. In which region I can calculate the potential?
Distance
Sir,
where
q.
there is
Yes?
Sir, in the region given q.
Only in this region. Okay. So I will make a image problem to this. I will take the things like this, q here, and I will remove this conducting planes. I will remove them, and I will just have the imaginary. I mean, imaginary means nothing is there. Just on that point, I will try to make the potential 0 by putting the charges. चेक करो एक बार, क्या पोटेंशियल 0 है अब इस दोनों पॉइंट्स पे? स्टिल by putting the charges. Is it 0?
Yes, sir.
So that's why they are called image charges. Okay? Because like if these were mirrors, how many number of images will form? You know that na formula? 360 by
upon n
n.
Theta
-1
I mean by theta
-1.
and
minus
minus 1.
1.
This is number of images. So here it is 360 by 90 minus 1. So 3 images are formed. So you can see 1, 2, 3 images. That's why it is called image problem. Okay. Now calculate if this was distance, you can write the coordinates now. Same here, we can write the coordinates and we can calculate the potential. And suppose you want to get the force, then the problem is this. Now, the problem is this, that you have this charge, you want to get force, and charges are kept like this, minus q, plus q, minus q. So you have done this problem, na? This type of problem. This, on this, it will be attracted like this by force F. It will be attracted like this by force F, and it will be repelled by this by force not F, but how much? So if I take this distance 2a, this distance will be 2a root 2, correct? Side root 2.
Yes, sir.
So what will be the force? So if F is 1 upon 4 pi epsilon naught q by 4a square, this force will become F dash is equal to 1 upon 4 pi epsilon naught q square by this square. It will become 8, na? 8a square. So just half of this. So it will become F by 2. Dekho, is it okay? Now this is simple vector problem. You just take the components. So this is angle theta, suppose. So this side you will get 2f
Cos theta.
cos theta. And this side it will cancel. F sin theta and F sin theta will cancel. 2f cos theta this side and F by 2 this side. So I can write F by 2 minus 2f cos theta. And theta is what? 45, na?
Yes.
So this will become F by 2 minus 2 times F by root 2. So take F common, it will become 1 by 2 minus root 2. So this will be how much? F into 0.5 minus 1.414. So if you subtract this, that means it will come out to be negative, means this charge will be finally going in this direction. Force will be, final force will be acting on this in this direction towards the center. समझ आ गया भाई? Note down.
वो नीचे का थोड़ा सा दिख नहीं रहा है
कितना आ जाएगा माइनस करने के बाद? इस तरफ फोर्स कितना लगेगा? -1.4
minus 0.9. If
0.5 minus 0.9. So this side minus 0.9 F. And what is F? This much. Okay? क्लियर है सबको? मिटा दूं?
One minute.
सर मेरे एक जिनिस ऑब्वियस लगता है, ये जो ग्राउंडेड इंड्यूस चार्ज सॉरी सरफेस पे ऊपर तो ग्राउंडेड है, तो इंड्यूस चार्ज क्यों ग्राउंड पे नहीं जा रहा है?
मतलब यू वांट टू से कि इंड्यूस चार्ज 0 रहे, ऐसा कह रहे हो?
हाँ, मेरे को तो वही लगता है, क्योंकि ये तो कंडक्टर है, कंडक्टर के ऊपर तो चार्ज ऊपर में ही तो होता है, तो अगर ग्राउंड करे तो चार्ज तो नीचे जाना ही होगा।
तो अगर तुम वो कैलकुलेशन करोगे, मान लो चार्ज के फ्लो का, और तो कंडक्टर में तो इनफाइनाइट अमाउंट ऑफ चार्ज है, तो जब ये क्यू चार्ज रखा हुआ है तो देयर विल बी ऑलवेज चार्जेस दैट विल शो अप टू दिस, ओके, राइट?
यस सर।
तो हमेशा ही क्यू चार्ज, जब तक ये क्यू चार्ज रखा हुआ है, नेगेटिव चार्ज विल शो अप टू दिस बिकॉज ऑफ इंडक्शन। बट आई विल थिंक अबाउट इट कि कोई कैलकुलेशन अगर मैं दे सकूं। ओके,
ठीक है।
one question is like this, that you have a surface like this, and this suppose x, y and z, and this charge q is held here at a distance d above this infinite ground conducting plane, infinite grounded means you can make this notation, conducting plane, and if you think about this system, don't consider the gravity, okay? Gravity is very small, you know. If you consider the forces like electromagnetic forces, force due to field and force due to gravity, this is say 10 to the power 34 or some number like this, okay? So we can neglect the gravity. So don't consider gravity as a force here. Only force is suppose this electrostatic force. Now जैसे ही तुम ये Q चार्ज यहाँ पे रखोगे, because negative charges appear on the conducting plane पे negative charges appear हो जाते हैं, negative charges appear, so they will attract that charge, obviously, and the charge will start accelerating towards the sheet. So you have to get the velocity before the charge hit the sheet. So velocity of the charge before hitting the plane. Before hitting the plane, you have to calculate the velocity. So again, force is how much? 1 upon 4 pi epsilon naught. Remember, q square by 4.
Z square.
Z square.
4. Let me take z square at some distance z. Okay.
हम Z minus D put नहीं करेंगे.
4D स्क्वायर में होगा.
4d स्क्वायर तो यहाँ पे फोर्स होगा. ओके.
Yes,
अगर मैं
sir.
कोई डिस्टेंस z ले लूं तो फोर्स इतना होगा, राइट? सो व्हाट इज फोर्स इज इक्वल टू v ma. Force is ma, yes or no? So ma is equal to, this all is, let me say, 1 upon 4 pi epsilon naught q square by 4 1 by z square. This is the force. And acceleration is how much? dv
d
by
square
dt.
dt, and that is equal to dv by dz into dz by dt. So that is equal to v dv by dz. Okay, v dv by dz. So you take this here. So v dv by dz is equal to, I am taking mass also this side, alpha 1 by z square. Let us put all the constant in alpha. So v dv will become alpha dz by z square. So let us now integrate both sides. When your z is at d, जब z d था, then velocity, let us take 0 because it was stationary. And when z is 0, before hitting the plane, the velocity, let's say, becomes v. That velocity we have to calculate. So this will become v square by 2 is equal to alpha. This will become minus 1 by z. ये कितना बन जाएगा? Minus
V square by 2 is equal to alpha minus 1 by z d2 0.
sorry, कितना हो गया? At when z is at d, then velocity is 0, and
v square by 2 equal to alpha by d.
no, 0 भी तो है.
So 1/0 ही जा रहा है ये तो.
मतलब velocity बहुत large हो जाएगी when it will be very very close. So उस चीज को we have to handle just, let me put epsilon. Epsilon is very small. Just before hitting it is still at a distance epsilon. Okay. So it will come out to be alpha minus 1 by na. So 1 by d minus 1 by epsilon. Then you have to put the value of epsilon. कितनी ऊपर, बहुत थोड़े में भी तो वो नंबर आपको पुट करना पड़ेगा. The velocity will keep on increasing as you approach towards this. So this is the velocity profile.
सर ये D2Z DT2 करके भी कर सकते हैं ना, मतलब V dV by dt ना करके.
तो तुम ऐसा करना चाहोगे कि पहले z निकालो और फिर z को डिफरेंशिएट करके v निकालो.
हाँ मतलब ये जीरो का जो इन्फिनिटी हो रहा है उसके कारण बोल रहा हूँ.
वो नहीं होगा, वो तो तुम कहीं से भी जाओगे तो वेलोसिटी तो लार्ज होनी ही है व्हेन इट विल बी वेरी वेरी क्लोज टू द, बिकॉज एक्चुअली फोर्स क्लाइंब अप करता जा रहा है ना, तो
Yes, sir.
एक्सेलरेशन इज आल्सो क्लाइंबिंग अप. सो वो तो आई मीन ये जो नंबर होता है एक्चुअली व्हेन यू आर वेरी क्लोज वेरी क्लोज वेरी क्लोज, सो दैट इज इन द टर्म्स ऑफ नंबर्स, राइट? So you can put the number and get that large velocity. It is like that.
Okay, sir.
After hitting velocity decrease होती जाएगी.
क्या बोल रहे हो?
ये प्रोफाइल तो वेलोसिटी की बिफोर हिट करने की है. सर आफ्टर हिटिंग.
After hitting, we don't know what will happen. एक बॉल आके जमीन पे गिरी, उसके बाद क्या हो रहा है?
पका के फिर से उठेगी.
तो क्या पता है उसका क्या इलास्टिसिटी है? वो तो सब फिर क्वेश्चन की बात है ना, कि क्वेश्चन में डिटेल्स होनी चाहिए. तो तभी तो जो ऐसे क्वेश्चंस में दिया होता है कि वो 1/2 ऑफ दैट हाइट वापस उठती है. तो इस टाइप से फिर इन अ वे आपको दिया जाता है कि कितना कोलिजन के बाद कितना उसका हुआ. तो क्वेश्चन ये भी आपको सीखना है कि जितनी बातें क्वेश्चन में पूछी गई बस उतना ही सोचना है. समझ रहे हो कि नहीं समझ रहे हो? जो जो चीज गिवन नहीं है उसके बारे में आप कैसे सोच सकते हो? पता चला ये कैलकुलेशन नहीं कर पा रहे हो और ये जरूर सोच रहे हो कि टकराने के बाद क्या होगा. टकराने के बाद का कुछ गिवन नहीं है, सो वी कांट से व्हाट विल हैपन. ओके, कैन आई रेज दिस?
Yes, sir.
ओके, तो इसमें तो किसी को अब कुछ नहीं पूछना. ओके, so this will be the part. I have told you that we will discuss 3 parts, right? So 2 parts we have discussed. What was the first?
Laplace Poisson equation. Second is image problem. Third is multipole expansion.
The first was Laplace equation. Second was image problem. And third is multipole expansion. all of the three are mainly to get the potential. All of them are to get the potential, and using potential, you can calculate so many things. Okay?
Yes, sir.
So the next one is the third one, and that is multipole expansion. Multipole expansion.
देख नहीं रहा.
Okay. Now, what is multipole expansion? Again, this will be a method to write the potential. So using multipole expansion, what we will write? Sometimes we write it by phi, sometimes we write it by v, but it is the potential that we will write. Using multipole expansion, we will write the potential. So please understand this concept that if there is certain volume, suppose, and it is consisting of charges. Charges are there, some volume charge, surface charge, everything is there. So we are considering a bulk, so there will be a volume charge density. So this system of charges, I mean charge densities, will have single charge, that is called monopole. Charges arranged like this, Q and minus Q, that is called dipole. Charges arranged like this, Q minus Q, Q minus Q, that is called quadrupole. And similarly, charges arranged like this, Q minus Q, Q minus Q, Q minus Q, Q minus Q. This is called octopole. And similarly, other configurations can be made. So in this, number of poles is 1. Number of poles means type of charges. Plus Q and minus Q. Number of poles is 1. Here number of poles is 2. Here number of poles is how much? 4. Here number of poles is 8. This is called dipole. This is called monopole. Monopole. Mono means single charge. This is called dipole. Di means 2. This is called quadrupole. And this is called octopole. Octopole. So you can think of breaking down this charge system made up of these type of configurations. So our job is to calculate the potential because of this charges, and that will be due to monopole, dipole, quadrupole, octopole, plus dash 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 others. This trend will be up to infinity, but we will only take monopole, dipole, quadrupole. That much is sufficient. ये बहुत ही ज्यादा आसान करके मैंने आपको बता रहा हूँ, तो इसलिए इस चीज को ध्यान से सुनो, नहीं तो पूरा पढ़ते जाओगे, इतनी मैथमेटिक्स आएगी एंड यू विल नॉट अंडरस्टैंड दैट व्हाट यू आर एक्चुअली डूइंग. So you are given a charge system. This is, I am taking in 3 dimension. Okay, bulk is there, and that charge system can be broken down into the charges, dipoles, quadrupoles, octopoles, like that. And we can write the net potential due to this charge system be made up of monopoles, dipoles, quadrupoles, octopoles, dash dash dash. This is called multipole expansion. Because this will be an infinite series, this is called multipole expansion. So if I can write a formula in which charge density rho is there, because here rho will be given. So if using rho I can write a formula, I will get the contributions of monopole, dipole and quadrupole, and that will be known as multipole expansion. All right. ये देखो, ये क्लियर है, समझ आया? So like you have seen, if I take number of charges here potential, and here electric field. So if number of charges is 1, potential is given by 1 by r, electric field is 1 by r square. Number of charges is 2, means dipole, potential is given by 1 by r square, field is given by 1 by r cube. Number of charges 4, potential is given by 1 by r cube, and this is given by 1 by r to the power 4. And number of charges 8, it is given by 1 by r to the power 4, and this is given by 1 by r to the power 5. So if it is L, तो order में लिखेंगे तो कैसे आएगा? It is getting like, if you write it in order, let's say order will start from the number of charges. So you can write it as 0, 1, 2 and 3, and this side you can write L, and here you can write 2 to the power L. Okay, क्योंकि दो के combination में है ना, 2 to the power 0, 2 to the power 1, 2 to, and here what you will get, 1 upon r to the power
2 to the power L.
Here it is L, na? See,
L minus 1.
L plus 1.
L minus 1.
Here it
Plus
is 3, here
L
it is
plus
4.
1.
L plus 1.
L plus 1.
And here
L plus 2.
L plus 2. So it is like this.
Sorry, here L means?
L means कितने number of coupled charges, because 2 2 के टर्म में बढ़ रहे हैं ना, तो पहला वाला 2 to the power 0 है, दूसरा वाला 2 to the power 1 है, तीसरा वाला 2 to the power 3 है, फिर 2 to the power 4 है. तो मोनोपोल मींस क्या है? 2 to the power 0 pole. Dipole means 2 to the power 1 pole. Quadrupole means 2 to the power 2 pole. Okay?
Okay, sir.
तो अब एक एक करके हम लोग को इनके बारे में फिर से पढ़ना पड़ेगा. मोनोपोल, डाइपोल, quadrupole and octopole. So at least monopole, dipole, quadrupole is important. Okay?
Q नॉट जगह
Now,
V नहीं आना चाहिए.
क्या?
आपने V की जो इक्वेशन लिखी है ना, Vm plus Vd plus Vq,
हाँ,
वो लास्ट टर्म Vo नहीं आएगी ना, पोटेंशियल ड्यू टू ऑक्टापोल.
क्या कह रहे हो यार? तुम्हारा पता नहीं कैसे डाउट रहते हैं. क्या बोल रहे हो?
आपने वो जो V इक्वल टू Vm plus Vd plus Vq लिखा हुआ है ना,
हाँ,
तो सर उसमें जो लास्ट टर्म है वो Vo नहीं आएगी, आपने Qo लिखा हुआ है.
अरे ठीक है यार, तो गलती से लिख दिया, इसमें क्या है? तुम ये नहीं ध्यान दे रहे हो क्या डिस्कस हो रहा है, तुम उसको देख रहे हो, तो ठीक है, वो तो समझ में आ रहा है कि कॉन्ट्रीब्यूशंस ऐड करके लिख रहा हूँ। ये समझ में आया क्या डिस्कस हो रहा है यहाँ?
यस सर।
बताओ जरा, ये कैसे बढ़ रहा है?
सर फर्स्ट फॉर मोनोपोल, सेकंड फॉर डाइपोल, थर्ड फॉर क्वाड्रुपोल एंड लास्ट फॉर ऑक्टापोल।
2 टू द पावर में क्यों बढ़ रहा है?
नहीं समझ।
बिकॉज इन अ वे आप पेयर ऑफ चार्जेस के फॉर्म में ही पूरे सिस्टम को लिखने की कोशिश कर रहे हो। ओके, तो पहला चार्ज छोड़ के सब में फर्स्ट में क्या हो जाएगा? 2 टू द पावर 0, this will be 2 to the power 1, this will be 2 to the power 2, this will be 2 to the power 3, like that. So अब हमें क्या पढ़ना पड़ेगा? What we will have to discuss, that how to write potential for monopole, that we already know, 1 upon 4 pi epsilon naught q by r. How to write for dipole, how to write for quadrupole, how to write for octopole. So at इतनी की जरूरत नहीं है, just monopole, dipole, quadrupole will be enough. And please understand one more thing, because if you see the formula, potential is decreasing in contribution ना. ये बहुत बार ये क्वेश्चन पूछा जाता है, इसका कंट्रीब्यूशन कैसा है? 1 by r, इसका 1 by r स्क्वायर, इसका 1 by r क्यूब, इसका 1 by r to the power 4. So there is something called far field approximation. Far field approximation. So if this term is alive, this will dominate, because see, these terms are smaller when seen at large r. Yes or no? So if this is alive, you will take this as the. So once they ask a question in which suppose a quadrupole was made like this, all other terms are 0. So what is the far field potential? Tell me. 1 by r to the power 4. तो एक चार्ज सिस्टम था, उसमें डाइपोल 0, मोनोपोल 0, डाइपोल 0, क्वाड्रुपोल 0, sorry, monopole 0, dipole 0, quadrupole 0, and octopole was not 0. So this will dominate. But in the same system, if this monopole is there, then this will dominate at large distances, because 1 by r is greater than 1 by r square is greater than 1 by r cube is greater than r to the power 4. This understood, everybody? This is called far field approximation. So if you calculated monopole and that became 0, what is the dependence of potential? Tell me.
Independent of origin.
No, that is okay. If you calculated monopole and that is 0, what is the dependence of potential for that system?
1 by r square.
No, you can't say that. You will say then I will calculate dipole.
Dipole.
If that
Set
is
करना पड़ेगा.
finite,
Yes sir.
then it is 1 by r square. If maybe dipole also goes to 0,
Yes sir.
Then
Quadruple पे
quadruple.
जाना.
quadrupole. And if that also becomes 0,
Octuple पे जाना.
So one time 5-mark question was मोनोपोल भी 0 हो गया, डाइपोल भी 0 हो गया, ऑक्टोपोल भी 0 हो गया, तो डिपेंडेंस क्या हो गया? सॉरी, मोनोपोल, डाइपोल, क्वाड्रुपोल 0 हो गया, तो डिपेंडेंस
Octuple.
Octuple हो गया.
ठीक है ना? तो नाउ वी हैव टू लर्न स्टेप बाय स्टेप मोनोपोल का, डाइपोल का, क्वाड्रुपोल का, ऑक्टोपोल का, इन सब का पोटेंशियल्स हम लोग एक बार दोबारा से डिस्कस करेंगे, एंड दिस पार्ट will give you 100% one question. Okay, so let us discuss one by one. तो सबसे पहले मोनोपोल, विच इज मोस्ट सिंपल. Monopole. Monopole means plus Q charge. You know this. At a distance R, what will be the potential? Tell me. 1 upon 4 pi epsilon naught.
Q by R.
Q by R. What is the field? 1 upon 4 pi epsilon naught. Q by R square. Put vector. Put R cap. This is the field. So monopole is okay. This you already know. Note down this. Simple. ये इसमें किसी भी को भी डाउट नहीं होना चाहिए, जो पूरा सेक्शन डिस्कस हो रहा है. और प्लीज नाउ prepare the electrostatics. I'll be floating the test as soon as this finishes. So prepare the complete electrostatics. Okay? Are you revising, everybody?
Yes, sir.
साथ साथ में रिवाइज
Yes,
कर
sir.
रहे हैं?
Yes, sir. Day to day basis.
Yes, sir.
किसी भी टाइप का कोई डाउट है आप क्लास में पूछो, बाद में भी आप कॉल कर सकते हो, व्हाट्सएप कर सकते हो. ठीक है? EMT में आपको बहुत मजा आएगा अगर आपकी चीजें क्लियर हो जाती है ना, तो इट गिव्स वेरी मच सेंस ऑफ सेटिस्फैक्शन. सो कोई डाउट आ रहा है, कोई प्रॉब्लम आ रही है, तो आप ये भी पूछ सकते हो कि हाउ टू स्टडी या इसमें इस चीज को कैसे करना है. यू हैव माय नंबर इन द ग्रुप. और सही डायरेक्शन में सोचना शुरू करना है. मैं सिर्फ एक चीज के लिए हमेशा आपको इंसिस्ट करता रहूंगा, दैट आई कांट लीव. मैं चाहता हूँ थोड़े टाइम में आप बिल्कुल बढ़िया से आप जिस डायरेक्शन में एग्जाम है उसी डायरेक्शन में सोचना शुरू करो. ठीक है वरुण?
Yes, sir.
ये नहीं कि चार्ज गिरेगा तो पड़ोसी के घर में चला जाएगा, ये सब नहीं सोचना है. ओके? तो टेस्ट के लिए प्रिपेयर करो अच्छे से एवरीबॉडी. नेक्स्ट थिंग इज डाइपोल. You will not find a paper without dipole. So dipole, you can make a physical dipole like this, Q and minus Q. ये class 12th में भी आपने पढ़ा हुआ है. And this is the center, and let's take the distance as say D or 2D. Okay? And I will take it as 2D. And then we will write a potential V at a point. So it will be because of this R1, this is R, and this is R2. And let's say this is theta. Okay? And we define dipole moment P is equal to 2QD. And distance of D is from negative to positive. So now again, when you calculate the potential, how you will get it? Tell me. Batao Varun. Potential at P.
4 pi epsilon naught Q by R1 minus Q by
Very
R2.
good. Plus or minus?
Sir, plus आएगा. Minus plus. Q by
No, no.
R2.
Q by R1 plus
Q by
minus
R2.
Q by R2. तो स्केलर क्वांटिटी है ना, इसमें साइन लेंगे. ठीक है? तो क्या बन जाएगा? Q you can take common and it will become 1 by R1 and minus 1 by R2. Okay? ठीक है वरुण?
Yes, sir.
अब जरा बताओ R1 और R2 की वैल्यू. R1 स्क्वायर विल बी
R plus
R
R
स्क्वायर
square
प्लस D स्क्वायर
D
माइनस
square
2
plus
RD
2D R cos theta.
और R2 स्क्वायर.
R
Now this angle will be considered, which is 180 minus
theta.
theta. So this will become R square plus D square plus 2 RD cos of theta. So when you put it, the potential becomes 1 upon 4 pi epsilon naught 2 QD cos theta by R square. You make an approximation that R is greater than D. Then you get this and you can write it like this 1 upon 4 pi epsilon naught. देखो इधर ध्यान से P dot R cap by R square. This is the potential. This you have been seeing since your class 12th. You put it under root and then take common, apply binomial expansion. But finally you should remember this. तो डाइपोल का पोटेंशियल कैसे जा रहा है 1 by R square. आ रहा है ना?
Yes, sir.
And field? What is the electrostatic field when you know the potential? E is equal to minus
Grad.
grad of V. So when you apply the grad in R theta, I mean in XY plane, phi 1 will become 0 because there is no phi term. So field, ये सबको याद रखना है. The field will come out to be P by 4 pi epsilon naught R cube into 2 cos theta R cap plus sin theta theta cap. This is the field of the dipole. Everybody should remember this. You will not have time to apply gradient and get this field, but you can do it for your own interest. Del की वैल्यू grad की वैल्यू लेके इस पे अप्लाई कर सकते हो. Open this as PR cos theta and then apply it. You will get this. Okay. So now this was the dipole. This was the point P. This is theta. This was plus Q. This was minus Q. Please see this. If P comes on this point, axial point here, theta will become 0. So there will be only radial field, and that it should be no theta cap, only R cap. R cap is, this is origin, so only field will be this side, right? देखो दिखाई भी दे रहा है. But if you are at this point, you will have a radial field, R cap also, and theta cap also. So two components of field will exist here. This component of R cap is known as ER, and this component of theta cap is known as E theta. So both will be present at a general point P. So ये ऐसा होगा जब ऐसे से करके यहां पहुंचोगे तो only this will be present, this will become 0. And if you come at this point where theta becomes 90, then no radial component. So at this point, only field will be in this direction, E theta. No radial field. At this point, only field will be ER, no theta cap. You can see by putting the angle theta. At this point, theta will become 180. So only radial field in this direction, ER, no theta. At this point, theta will become how much?
180 per theta.
How much?
3 pi by 2.
3 pi by 2. So 3 pi by 2 means no radial term, only ये वाला term नहीं होगा ना, only
Minus
theta
theta.
term. There is some, just a second. If I take it here, what will be the direction? So यहाँ से field ऐसे निकल रही है. It is going like this. Here also field is coming. It is going like this. So it will be like this. Correct? Only now ask if there is any doubt in this.
सर साइन 270 का तो वैल्यू -1 होता है ना, तो डायरेक्शन तो ऊपर होना चाहिए.
थीटा कैप किधर होगा? थीटा
Towards-
कैप ऊपर होगा तो माइनस थीटा कैप नीचे हो जाएगा ना. थीटा कैप इज इन द इंक्रीजिंग डायरेक्शन ऑफ थीटा. तो देखो थीटा कैप इधर 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 इधर, यहाँ पहुंचने पे इधर.
अच्छा हाँ हाँ ठीक है सर.
दैट इज ओके. और वैसे भी देखो ना, तो पॉजिटिव चार्ज से फील्ड निकल रही है ना ऐसे. इट विल बी कमिंग लाइक दिस एंड एंटरिंग लाइक दिस ना, फॉर द डाइपोल. करेक्ट?
यस सर.
Like this. So this dipole field everybody should know. तो एक चीज और ध्यान देना कि if this is the dipole P, what is field here? And what is field here at equal distances? Please see, here theta will become 90. Huh? So this term will be gone. Only this term will be there. So here field will be P by 4 pi epsilon naught r cube. Am I right?
Yes sir.
And here theta is 0. So here field will be 2p by 4 pi epsilon naught r cube. So यहाँ का दुगना field यहाँ होगा. यानी field, this is called axial. This is called equatorial. इस point को क्या बोलते हैं? Equatorial, perpendicular to the axis. Equatorial, axial. So field is double as equatorial point.
सर ये थीटा की डायरेक्शन नेगेटिव साइड में, मतलब वो डाउनवर्ड कैसे आ रही है, मुझे समझ में आ रही है.
कौन से पॉइंट पे? यहाँ
नहीं, वहाँ उस अपोजिट पॉइंट पे।
तो बस यही पकड़े रहो। ये पहले समझ में आता है कि आर कैप इधर है, थीटा कैप इधर है।
हाँ,
कैसे?
पॉइंट
क्योंकि
पे
आर
ही।
कैप इज इन द इंक्रीजिंग डायरेक्शन ऑफ आर एंड थीटा कैप इज इन द इंक्रीजिंग डायरेक्शन ऑफ थीटा। इफ यू पुट इट लाइक दिस, थीटा विल इंक्रीज। इसी को पकड़े पकड़े यहां पहुंच जाओगे तो क्या होगा? आर कैप विल बी इन दिस डायरेक्शन, थीटा कैप विल बी इन दिस डायरेक्शन, राइट?
यस,
But because of minus sign, it will become this.
ओके। हाँ, ओके, फर्स्ट वन।
So any question from this up to this? You got the dipole field, dipole potential. Is it okay? This much is okay? कितना समझ आ गया? चलो बाकी next class में discuss करेंगे. If you have any doubt, please ask. Otherwise, we will discuss in next class.
सर, ये जो
Yes.
मल्टीपल एक्सपेंशन करते हैं, इसका कोई क्राइटेरिया है? मतलब अगर हम चार्ज डिस्ट्रीब्यूशन का खूब मतलब आर इक्वल टू वेरी लेस, मतलब उसका सम ही है, तो उसके केस में भी हम मल्टीपल एक्सपेंशन कर सकते हैं, मतलब मोनोपोल प्लस डाइपोल।
मैं तुम्हें बता रहा हूँ, जब तुम डाइपोल की वजह से इलेक्ट्रिक फील्ड लिखते हो, ठीक है, जब अभी मैंने पोटेंशियल लिखा था ना कोसाइन लॉ लगा के, ये वाला, तो इसमें जब मैं अप्रोक्सीमेशन करता हूं तब ये आता है। क्या अप्रोक्सीमेशन करता हूं? यहां पे मैं अप्रोक्सीमेशन करता हूं कि R इज मच मच ग्रेटर देन D। अगर ये ना करूं तो बाइनोमियल एक्सपेंशन में ही इनफाइनाइट टर्म्स लेने पड़ेंगे। यस और नो?
यस।
दैट इज मल्टीपोल एक्सपेंशन। तो यानी कि अगर आप कोई अप्रोक्सीमेशन ना लगाओ तो नेचुरली यू हैव मल्टीपोल एक्सपेंशन। इफ यू डोंट पुट एनी अप्रोक्सीमेशन, then what you get is multipole expansion. Okay?
Yes, sir. Got it, sir.
तो इवन सिंगल चार्ज लेके उसका पोटेंशियल लिखो और कोई अप्रोक्सीमेशन मत लगाओ, यू विल गेट इनफाइनाइट सीरीज और उसमें सारे टर्म्स आ जाएंगे, मल्टीपोल एक्सपेंशन आ जाएगा। ओके?
यस सर।
सर, इट मींस दैट डाइपोल के जो इक्वेटोरियल पॉइंट होता है वहां पे पोटेंशियल ऑलवेज जीरो रहेगा।
अभी तो आपने अप्लाई किया इमेज प्रॉब्लम में, नयन।
यस सर।
इमेज प्रॉब्लम में आपने वही तो अप्लाई किया। ये देखो, ये डाइपोल ही तो था, Q और माइनस Q।
यस सर।
और ये इसकी इक्वेटोरियल लाइन है, तो इस पे हर जगह पोटेंशियल क्या हो जा रहा था? जीरो। समझ आ गया आप कनेक्शन?
यस सर।
दिस इज गुड क्वेश्चन। अब आप देखो जरा ध्यान से, व्हाट वी डिड हियर, this is like a dipole and this is equatorial line, and on the equatorial line potential will be always zero. तो इंटरेस्टिंग लग रहा है भाई सबको? अच्छे से मजा आ रहा है? समझ आ रहा है?
यस सर।
Okay, others can also respond.
Yes
They
sir.
can also. समझ आ रहा है EMT अच्छे से?
यस सर।
यस सर।
चलो, कोई भी डाउट है तो आप डिस्कस करते रहना। आई एम ट्राइंग टू टीच यू बिल्कुल टूवर्ड्स योर एग्जाम, क्योंकि EMT तो ऑब्वियसली बहुत ब्रॉड है। मेरा एरिया ऑफ रिसर्च भी मतलब यही डोमेन रहा है पूरा, इलेक्ट्रोमैग्नेटिक्स ही। तो वी कैन गो एज फार एज वी वांट, बट सीइंग द एग्जाम थोड़ा रेस्ट्रिक्ट करके अपने माइंड को चलना है ताकि हमारी परफॉर्मेंस बेटर हो। ओके? चलो, थैंक यू सो मच।
थैंक यू सर।
थैंक यू सर।